My channel name is Easy Engineering 531. It is very useful for polytechnic students as well as engineering students. You can watch this in YouTube. Please like, share and subscribe Easy Engineering 531 channel. Today we are going to see about the Thevenin's theorem, and we are going to use this kit and solve the Thevenin's theorem experiment. So this is the Thevenin's theorem kit, and we are having 12 volt power source, and this R1 is constant value and R3 is also constant value, and this R2 and R4 can be adjusted, but we are going to the maximum and we are keeping this R2 and R4 as constant, and to find the voltage here and to find the load current here. And this is RL, that is load resistance. This load resistance can be varied using load resistance adjuster. So according to this, we are giving source to see minus to minus and plus to plus, and we are keeping R1 equal to 68 ohms, R2 equal to 2.50 kilo ohms, and R3 equal to 450 ohms, and R4 equal to 2.24 kilo ohms. These four values are constant, we are keeping constant. And see, to find the load current, we are fixing a ammeter, that is milliamps, 0 to 30 milliamps. See, fixing a milliammeter to find the load current, and we are going to adjust the RL to RL, and we want to calculate that load current here. So the power button is switched on, and by adjusting this we are keeping the load current, getting the load current as 5 milliamps. Now we are going to find out the RL, that is load resistance, according to this diagram by using the kit. So now the connection is given here. See, you can see, to find the RL according to that circuit diagram, we are using the multimeter, and we are keeping the ohms here 20 kilo ohms, and we are getting 1.53 kilo ohms. So we got 1.53 kilo ohms according to this diagram. Next, we want to find out Thevenin's voltage. So we want to connect the circuit as per this diagram. So in the kit we are connecting as per that circuit diagram. So we are connecting to find out here voltage, that is V Thevenins. So we are going to switch on this, and you can see we are getting 10.79 volt or 10.80 volt. So according to this diagram, we have given connection in the kit, and we got V Thevenin's equal to 10.80 volt. Next, we want to find out the RTH, that is Thevenin resistance. So we need to short circuit and give the connection according to this circuit. So we are changing the connections. You can see it is short circuited, and we are going to calculate RTH, that is Thevenin's resistance. So we are connecting here, and we are going to keep the multimeter in ohms position, 20 kilo ohms, and we are getting 0.48 kilo ohms, 0.48 kilo ohms, and you can see according to this diagram we got RTH equal to 0.48 kilo ohms. So all the datas we have taken or written here, and we should find out this current. So VTH equal to 10.80 volt, RTH equal to 0.5480 kilo ohms, and RL equal to 1.53 kilo ohms. So by using this formula, I equal to VTH divided by RL plus RTH. So VTH is 10.80 from here, and R equal to 0.480 plus 1.53 into 10 to the power of minus 3 or kilo ohms. By solving this, we are getting 5.37 milliamps. So first for the load current, we got IL equal to 5 mA. The next you are getting I equal to 5.37 mA. So 0.37 is the error, and we got the. Then for the next, we are going to do for the we are adjusting the load resistance with the first of all we are going to find out the load current. So same procedure as followed for this should be followed for this, and we are adjusting the load resistance, and we are getting load current equal to 10 milliamps. So the second reading for load current equal to 10 milliamps, we are getting RL equal to 0.58 kilo ohms, and Thevenin's voltage equal to 10.81 volts, and Thevenin's resistance equal to 0.57 kilo ohms. Third reading, load current equal to 50 milliamps, RL equal to 0.19 kilo ohms, Thevenin's voltage equal to 10.79 volt, and Thevenin's resistance equal to 0.489 kilo ohms. For fourth reading, IL equal to 20 milliamps, RL equal to 0.016 kilo ohms, and VTH, that is Thevenin's voltage, equal to 10.80 volt, and RTH equal to 0.488 kilo ohms. Going to calculate for IL equal to 10 milliamps, IL equal to 15 milliamps, and IL equal to 20 milliamps. To find out the current, I equal to VTH divided by RL plus RTH. So we are substituting in this formula. First for IL equal to 10 milliamps. So we are getting 9.440 milliamps. For 15 milliamps, we are getting 15.91 milliamps. And for IL equal to 20 milliamps, we are getting 21.42 milliamps. So the Thevenin's theorem is verified by using this kit, and the result is obtained. Thank you. Please like Easy Engineering 531 channel in YouTube, and share Easy Engineering 531 channel in YouTube, and subscribe Easy Engineering 531 channel in YouTube. Please like, share and subscribe.